The purported link between hormone-disrupting plastics chemicals like BPA and obesity was initially based in part on observations that the rise in chemical exposure seemed to coincide with the rise of the obesity epidemic, with graphs like these. But maybe that's just a coincidence. There's lots of other changes over the last half-century, like an increase in fast food consumption, watching TV, that would seem to be simpler explanations. But why are our pets getting fatter too? If Fido isn't drinking more soda. Of course, the more we watch Seinfeld reruns, the less we may walk the dog, but what about our cats? Well, maybe we're giving both them and our kids a few too many treats? That would seem an easier explanation than some pervasive obesity-causing chemical in the environment building up in the pet and person food chains. But how do we explain this? A study of over 20,000 animals from 24 populations, and we're all getting fatter. The odds that this could happen just by chance is like 1 in 10 million, large and sustained increases in body weight across the board, even in animals without access to vending machines or getting phys ed at school. So maybe some environmental pollutant is involved. Of course, we're exposed to a whole cocktail of new chemicals besides BPA, but the reason researchers have zeroed in on it is because of experiments like this, showing that BPA can accelerate the production of new fat cells, in a petri dish at least. But this was at more than 1,000 times the concentration found in most people's bloodstream. We didn't know if the same thing happened at typical levels until now. Most people have between 1 to 20 nanomoles in their blood, and even at 1 nanomole, a significant boost in human fat cell production. So even low levels may be a problem, but again, that's in a petri dish. What about in people? Why not just measure the body weights of a population exposed to the chemical compared to a population not exposed to the chemical? Because there is virtually no unexposed population. The stuff is everywhere. OK, then how about those with higher levels compared to those with lower levels? Good thinking, which is what researchers at NYU did, and the amount of BPA flowing through the bodies of children and adolescents was significantly associated with obesity. But since it was a cross-sectional study, a snapshot in time, we don't know which came first. Maybe the BPA levels didn't lead to obesity. Maybe the obesity led to high BPA levels, since the chemical is stored in fat. Or maybe BPA is just a marker for the same kinds of processed foods that can make you fat. What we need are prospective studies where you measure exposure, then follow people over time. We never had anything like that, though, until now, and indeed higher levels of BPA and other plastics chemicals were significantly associated with faster weight gain over the subsequent decade. OK, so how can we stay away from the stuff? Though we inhale some from dust, and some through our skin, touching BPA-laden receipts, 90% of exposure is from our diet. How do you tell? You have people fast and drink water only out of glass bottles for a few days, and their BPA levels drop as much as tenfold. Fasting isn't very sustainable, though. What if you did a 3-day fresh foods intervention, where they had families switch away from canned and processed foods for a few days? You can indeed get a significant drop in BPA exposure, or you can do the experiment the other way, adding a serving of canned soup to people's daily diet, and see a 1,000% rise in BPA levels in their urine compared to a serving of soup prepared with fresh ingredients. They used a ready-to-serve canned soup, which in the largest survey of North American canned foods has about 85% less BPA than condensed soups, which are even worse. But the worst of the worst appeared to be canned tuna.